Good morning, students. Today, in this session, I am going to explain about a decision tree, how we are going to implement the decision tree, along with entropy and the information gate. So, in the last class, in this unit, we have discussed this decision tree, what is decision tree, and the algorithm, which is ID3. And for that, we need to calculate the entropy and the information gain. So in a decision tree, the important thing is how we are going to find out the best node. For that, we need to calculate the entropy and decision tree. So theoretically, we have done that one. Now let us see a simple program, how we are going to run this decision tree program. See here, just a simple decision tree program I am explaining here in the Google Colab. So the very first step is we need to import uh, these two packages, that is pandas and numpy. Import pandas as pd and import numpy as np. And then after that, the very first step is we are going to define a class. That class is called as a simple decision tree. Why? Because in that decision tree only we are going to calculate the entropy, information gain. Later we are going to find out the best split, and then we are going to predict the accurate results. So for that, first we are going to define a class called as class simple decision tree. So this defines the custom decision tree class, that is the criteria equal to entropy, that is the class uses entropy to define the splits, and then self dot tree holds the final tree structure after training. For this reason, for this we are going to use this criteria equal to entropy, and the whole self dot tree holds the final tree structure after training. Next one, these are the helper functions to define this simple decision tree. Next one is entropy self comma y. Here we are going to calculate the entropy. I hope you remember the formula, that is minus p log of base 2 minus p of s log of base 2 probability of s minus probability of no log of base 2 probability of no. So that here we are going to make use of that formula here. Here the counts, this counts is nothing but the counts occurrences of each class in Y. Okay, that is 0 or 1, that is yes or no. Then probabilities, here it is normalizes counts to probabilities, and at last it is going to return the negative sum of probability of I into log of base to probability of I. And here just we are going to add a simple last this term 1e minus 1. It is a small term. Why? Because whenever we get some error while calculation, whenever there is a zero occurrence is there, to make use of those, to avoid that errors, we are going to make use of adding this thing while we are calculating the entropy. And when you add this particular term, there will be no difference in the results. And here, simple decision tree dot entropy equal to entropy. This decision tree is here, and the dot entropy is equal to this one. Next one, next we are going to calculate the information gain. So here information gain, we are calling self y comma x underscore column. And this calculates information gain for splitting on a specific feature. So what are the steps here? We are going to compute the total entropy of y, that is this one. Then split y based on unique values of x underscore column. Okay, so we have to find out that we are going to split y based on the unique value of this x underscore column. And we are going to compute the weighted entropy of the subsets, and we are going to subtract the weighted entropy from total entropy to get information gain. I hope you remember the formula. Information gain equal to entropy of whole data set minus weighted average into entropy of each individual feature. So that is what the same formula here we have written. So we are going to compute the weighted entropy of the subsets, and then we are going to subtract the weighted entropy. See here, we are going to subtract the weighted entropy from total entropy to get the information gain. Again, we are calling the same thing. Here, simple decision tree dot information gain equal to information gain. Now, next one is we found entropy and we find the information gain. The next step is we are going to find the best split. Okay. So here, this particular function identifies the best feature to split based on information gain. Yes, based on the information gain only, we are going to split the decision tree. For this here, we are going to write a loop. It iterates through each column, that is feature in X, and calculates information gain and returns the features with the highest information gain. We already know that we are going to calculate the information gain for each and every feature, and whichever is having the highest information, that we are going to take it as the root node. The same thing here we are doing. For that, we have created a loop, and it iterates through each column in X and calculates its information gain. And it is finally it is going to return the feature with the highest information gain. And again, we are calling this simple decision tree dot find underscore best underscore split equal to find underscore best underscore split. Next, we are going to build the tree. Yes, once we found the information gain, we are going to build some decision tree. And here we are going to identify the best feature to split on based on information gain. And, and here mainly recursively builds the decision tree. Recursively builds the decision tree. That is, if y contains only one unique value, then return that value. Otherwise, if x is empty, return the majority class in the y. Here, for this recursively build the decision tree, what is going to do is, it is going to find the best feature to split, and then it is going to split the data based on the unique values of the features. It's going to and it is going to recursively build subtrees for each subsplit. So what is happening here? Once after getting the information gain, we are going to get some value. Just let me explain here. So once we got some node here, we are going to get some tree. But here it may be reached to leaf node, but still there is something over here and something over here to further split the tree. At that time, again, it is recursively, it is going to follow the same procedure of earlier, like calculating the information gain and entropy. That that particular process is called as the recursively building the decision tree. That will be done. Will be done with the help of this code. Just here finding the best features to split, and we are going to split the data based on the unique values of the feature, and then recursively build subtrees for each split. That is what here this piece of code. Next, we are going to have another one, another function called as fit. So here fits the decision tree to the data. Yes, now we have constructed recursively built the decision tree. Now we are going to fit the data. That is fit the decision tree. Here for that it is going to call the build underscore tree to construct the tree and stores it in self.tree. Okay. So here then in this only, again, we are using one more function called as predict. Here it is going to predict the label for a single instance of X here and traverse the tree recursively. That is, if the current node is a feature, find the corresponding branch using X feature. Okay, try to understand. If the current node is a feature, find the corresponding branch using X of feature. And if the current node is the label, then returns the label. That is what. Okay. Next, and here this one. Then here, uh, next one is predict self comma X. Here it is going to predict the labels for all instances in X. That is applies predict underscore 1. Here you can see here predicts underscore 1 to each row in X using the apply function. So by make use of this apply function with the help of lambda function, it is going to predict the labels of all instances of EX. Okay. So this is what how we are going to fit the decision tree to the given data. And next, here comes just till now, we haven't uploaded any data set. Just we have written a piece of code. We have created a functions, and in each function, first we have written how to calculate entropy, how to calculate information gain, how to recursively build that tree tree, and before that how we are going to find the best split, and then how we are going to fit the data. In that we used other two functions called as predict underscore one and predict. Now here comes next, we are going to upload the data set. So in Google Colab, this is the piece of code required to upload a particular data set. So once you run this piece of code, it will ask you for choose file, and you are going to choose the file from your PC. Then it will be uploaded into Google Colab. Now, next thing we are going to do is we have to extract the dependent and independent variables. We know this is the data set. So these four are called as the independent variable, and this is called as the dependent variable. Okay. Here, before that, just here, I'm reading the CSV file. So for that, what we are going to do, pd.read underscore CSV, directly write down the CSV file. And values are, what values we have in this CSV file? We have outlook, temperature, humidity, wind, and play. That only here we have written. Next is here we are going to extract the independent and dependent variable. So independent variables are other than display. Remaining these four are the asking us to display these four independent variable. And the last one is the dependent variable, directly asking to print the print. Next one is we are going to train the decision tree. For that, I just have created a variable called as tree equal to simple decision tree. Where is this simple decision tree? Where here we have created a class called simple decision tree. That only we are calling here simple decision tree, and criteria equal to entropy. That tree dot criterion we are calling, and we are fitting the x variables and the y, that is independent variables and dependent variables. Then we are going to display the decision tree, that is print decision tree dot tree. So the tree is something this one. Okay. So it is going to print the tree in this one. For D1, no, D2, no, D3, yes. So day wise, it is giving the values. Now, the next step is, as this is a classification algorithm, we are going to predict the results. So, predictions equal to tree dot predict. What is that tree? The decision tree here. Predict, and we are going to print the prediction. So, for 0, prediction no. For 1, it is no. 2, yes. These are the rows, and these are the predicted values. And now, here, at last step is we are going to calculate the accuracy. We know how we are going to calculate the accuracy, that is number of predictions made by total number of predictions. So here simply we are given as predictions equal to y dot mean, and print we are printing this accuracy which is into float. So here we got the accuracy as 1. Why? Because actually is same and prediction is also same. That's why we got the accuracy as 1. But in general, we should not get the 100% accuracy, which it may lead to overfitting. And the decision tree limitation itself is the problem of overfitting. That if we manage that, if we try to overcome that, this limitation, decision tree is the best algorithm. Okay. I hope you have understood this program. Here, the main thing here is the how to calculate entropy and the information gain, the best split, and then how we are going to recursively build the decision tree until we reach to the leaf node. Thank you.